students, today we are coming with a few questions on domain and range. Okay, we'll take a few questions which are very important for the competitive exams. So in this section, we'll start with this first question of today. Find the domain of this function fx equal to log of x squared plus 5x plus 6 upon greatest integer function of x minus 1. The solution to this problem goes like this. Clearly, f is defined only if greatest integer function of x minus 1 is not equal to 0 and exactly same time, since it is coming with log, so x squared plus 5x plus 6 has to be exactly greater than 0, strictly greater than 0. So we have to find out the values of x which satisfy both the conditions. So greatest integer function should not be equal to 1. This is what we'll get from here. Means x must lie between close interval 1 to open interval 2. And for this we'll be getting x plus 2 into x plus 3 greater than 0. So we'll be getting x belonging to minus infinity to minus 3 union minus 2 to infinity. Okay, so domain of the function will be intersection of both this. Okay, intersection of both this means we'll get this minus infinity to minus 3 union minus 2 to 1 minus 2 to 1. This interval is coming under this, right? But it is coming under that. Again, minus 2 to 1 union 2 to infinity, but this 2 is not included here. This 2 is also there in this interval. 2 is there, but this 2 is not included here, so we have to exclude 2, and that is the reason why we have written like this. Okay, so that will be the answer to this question. Okay, 2. Find the domain of this function square root of log of modulus of x to the base greatest integer function of x. The solution to this problem goes like this. We'll go like this. Here the first step would be log of modulus of x to the base greatest integer function of x has to be greater than or equal to 0 because it is there in the square root. Okay, along with and greatest integer function has to be greater than 0 because it is there in the base of log and should not be equal to 1. So domain of this functionality will be ultimately given by the intersection of all these three. The greatest integer function greater than 0 and not equal to 1 will give us, these two conditions will give us x is belonging to 2 to infinity, right? Greatest integer function greater than 0 and not equal to 1 will give rise to this. Okay, and from here what we'll get is modulus of x will be greater than or equal to GIF of x to the power 0. Okay, that is modulus of x has to be greater than or equal to 1. That means x has to be belonging to 1 to infinity. right? So domain will be ultimately the intersection of A and B. Okay, therefore domain of F will be their intersection is what? 2 to infinity. So this will be the answer to this question. Again, we'll quickly move to the next question. Question 3. Find the domain of fx equal to, okay, let me write down this question, then again I will cut it afterwards. Fx equal to log of CIF of x to the base CIF of x plus log of fractional part of x to the base fractional part of x. Okay, the next question number 3, we are taking this. Find the domain of fx equal to this question. Log of greatest integer function of x to the base greatest integer function of x plus log of fractional part of x to the base fractional part of x. So here the answer would be the intersection of the individual domain of this function, two functions. Okay, so we'll take on both separately. Okay, we have to take these two functions separately. So for this to be defined, for the first function to be defined, we must greatest integer function has to be strictly greater than 0 and not equal to 1, obvious. Okay, and that will give us x belonging to closed interval 2 to infinity, right? And for this function, what we are going to get is fractional part of x has to be greater than 0. That means x must belong to all real numbers minus integers, because we know that integers fractional part is 0, so we have to subtract the set of integers from the real numbers. So domain of the function will be the intersection of these two, that is 2 to infinity, 2 to infinity, open interval. Already we have excluded the minus z also we can write, and we can write all the integers which are lying between this 2 to infinity. There are infinite what is it called, integers, so I have to write minus z. Okay, so domain will be open interval 2 to infinity minus all the integers. So this is the answer to this question. Again, we'll go for the next one. Okay, the next question coming up is this. Find the domain of this function fx equal to cos inverse of square root of log of modulus of x by x to the base CIF of x. Okay, so solution to this question goes like this. Okay, for logarithmic function to be defined, we must get for this. First of all, we'll solve for this, then slowly we'll move up the inside function. CIF, the base should be greater than 0 and not equal to 1. So this gives rise to x belongs to close interval 2 to infinity. So this one will give one equation, suppose A, okay, for logarithmic function to be defined. And along with this, we must get modulus of x by x has to be greater than 0. Means modulus of x by x greater than 0. This one is nothing but the signum function, the part of signum function, not exactly signum function. This one will give us two values: 1 if x greater than equal to 0, minus 1 if x is less than 0. So greater than 0, it has to give us 1, but a 1 we are not looking for. It has to be greater than 0. So from here what we'll get is x belonging to, sorry, this is what we are looking for, right? Modulus of x by x has to be greater than 0. So modulus of x by x is giving us 1. So we'll take this interval. So x belonging to 0 to infinity of an interval. Okay, so this one also will give one equation B. Okay, so ultimately the domain of this function will be intersection of A and B. That implies we'll be getting 2 to infinity, yes, 2 to infinity. Okay, cos inverse of this, okay, square root of logarithmic function. Okay, again. Okay, so that's the answer to this question. We are coming with the next question, that is this: find the domain of this function fx equal to sine inverse of log of greatest integer function of x plus log of sine inverse of GIF of x. Okay, so ultimately this answer will be the intersection of individual domain of these two functions. Okay, so solution will make it into two parts. First, we'll go for this first function. So here we must get GIF of x greater than 0 and not equal to 1, and we must get log of GIF of x lying between -1 to 1, because that is the range of sine inverse function. So from here we'll be getting x belonging to 2 to infinity. Okay, and for this function, this second function, we'll be getting this GIF of x must lie between -1 and 1, that is the range of sine inverse of x, and sine inverse of GIF of x has to be strictly greater than 0, right? That is what we must get. So this entire thing will imply now x belonging to 2 to infinity and log of this one is lying between -1 and 1, so we'll break into two parts. Log of GIF of x is greater than equal to -1 and log of GIF of x less than equal to 1. So we'll slightly modify this one as ZIF of x is greater than equal to 10 to the power minus 1, that is 1 by 10. So x will be belonging to closed interval 1 to infinity. Okay, 1 to infinity, this one. Okay, and this one will give us CIF of x less than equal to 10. So x is belonging to x will be less than equal to 10, so it will be minus infinity to 10 closed. So their intersection will be x belonging to 1 to 10. 1 to 10, instead of that we'll take 1 to 11. Okay, 1 to 11 open interval. Okay, this two is this. Now this one will give a. Now we will go for the second function. Okay, second function is coming with this. So this one will mean CIF of x is either minus 1, 0 or 1. Now sine inverse of minus 1, we know it to be less than 0, so it is not required because we are looking for positive values. Sine inverse of 0 is also, sine inverse of 0 is 0, so that one also we are not looking for. We are looking for a strictly positive value. So from here we'll be getting only sine inverse of 1, right? Sine inverse of 1. So from there we'll be getting x is belonging to, from here we'll be getting CIF of x is equal to 1, means x, because this is what it is required. The rest, these two are neglected because of these reasons. Okay, so CIF of x equal to 1 is the only thing we'll get from here. So x will belong to 1 to 2 open interval. Okay, so this one will be giving as b. So ultimate answer, domain of the function will be, okay, intersection of a and b, that is closed interval 1 to open interval 2. So that should be the answer for this question. Let's find the domain of fx equal to log of ZIF of cos of modulus of x plus half. Okay, the solution to this question will go like this. ZIF of cos of mod of x plus half has to be greater than 0 for logarithmic function to be defined. So since it is ZIF, so we'll be getting cos of mod of x plus half has to be greater than or equal to 1. Okay, so from here we'll be getting cos of mod of x is greater than equal to half. Okay, therefore this means cos of mod of x has to lie between greater than half, and we know that cos ka value, the greatest value can be 1. So for some time we'll take this one to be equal to modulus of x as t. We'll consider this one to be t. So ultimately we'll be looking for the values of t for which cos t is lying between half and 1. Okay, so this one will make two parts. Cos of t is lying between 0 and half. Let us draw the graph so that we understand it clearly. Okay. Try to draw the graph of cos x. Came from here, it is 2 pi. Here it is 0, is 1. Okay, and it will reach half when x equal to pi by 3. So we are looking for these values where x equal to t equal to rather greater than half and less than equal to 1. So these are the intervals we are looking for. So this is the interval we are looking for. So first thing we'll get is pi by 3. Then we'll be getting this one. This one will be pi by 3, right? This one is, this value will be 2 pi minus pi by 3, that is 5 pi by 3. Okay, so t will be lying between 0 to pi by 3 because we are looking for this interval. No, then this interval union 5 pi by 3 to 2 pi union and so on, right? So how to generalize it? What we'll write is, we'll generalize this result we are going to generalize. So how to generalize? T is lying between 2 and pi, 2 pi by 3 plus 2 and pi, or 2 and pi plus 5 pi by 3. T will be lying between this 2 pi plus 2 and pi. Okay, so ultimately we'll convert this result into x because we are looking for the values of x, not t. So x will be belonging to, ultimately will be giving the closed interval minus 2 and pi plus pi by 3 comma minus 2 and pi. Okay, closed interval union 2 and pi comma 2 and pi plus pi by 3 union, from here we'll be getting again closed interval minus 2 and pi plus 2 pi comma minus 2 and pi plus 5 pi by 3 close interval union 2 and pi plus 5 pi by 3 okay, comma 2 and pi plus 2 pi. Okay, 2 and pi plus 2 pi. So this will be the final answer. Okay, we are generalizing the values of x which are lying in this interval. Okay, we'll go for the next question. Okay, we are coming with the next question, that is find the domain of fx equal to sine inverse of cos inverse of modulus of greatest integer function of x. Okay, so we know that cos inverse फंक्शन का रेंज होता है 0 to पाई में. Okay, तो ultimately greatest integer function of x will lie between -1 and 1. Okay, so that means greatest integer function has to be equal to either -1, 0 and 1. So we'll try to find out the domain, that is the values of x from here. Okay, now we know that GIF of x will be equal to -1 for all x lying between -1 to 0 excluding 0, 0 for values of x which are lying between 0 to 1 excluding 1, 1 all values of x lying between 1 to 2 excluding 2. Now we'll make 3 cases out of it and we'll check which all values of x are satisfying the given function. So case 1, when x is lying between GIF of x is -1, that is x is lying between -1 to 0. Again, then the function fx will be equal to sine inverse of cos inverse of GIF of x will give us this sine inverse of cos inverse of -1. Cos inverse of -1 we know it to be equal to pi. So sine inverse of pi. Now you see pi, the value of pi is 3.14, right? And sine inverse function का domain है -1 to 1, right? -1 to 1 close interval. So clearly this value is not lying here, so it cannot be a value of sine inverse. Means sine inverse function is not defined for pi, so we have got undefined. Okay, for which values of x when lying between this, so this is out of the answer. So case 2, when GIF of x is 0, that is x will lie between 0 to 1, then the functional value fx will give us sine inverse of cos inverse of 0. So ultimately we'll be getting sine inverse of pi by 2. Again, the value of pi by 2 is 1.58, we can take 1.57. Then also it is not lying in the domain of sine inverse, so this is also undefined. Okay, so we are living with the third case, that is when x is lying between 1 to 2. Okay, we'll check this one. So what we'll get, sine inverse of cos inverse of GIF of x, that is GIF of 1. So cos inverse of 1. Cos inverse of 1 we know it to be equal to 0, so we'll get sine inverse of 0 and sine inverse of 0, and 0 is clearly lying between -1 and 1, so it is defined. So we are getting a value. So domain of the function will be all x lying between 1 to 2. Okay, find the domain of fx equal to 1 by GIF of modulus of x minus 1 plus GIF of modulus of 7 minus x minus 6. We have to find out the domain. So this one goes like this. So obvious case, modulus of x minus 1 GIF plus GIF of modulus of 7 minus x minus 6 should not be equal to 0. So since modulus of x is involved, so we'll make the intervals 1, first interval less than 1, next interval between 1 and 7, and the next interval greater than 7. Again, so we'll break it. So for x strictly less than 1, we'll be getting ZIF of, from here we'll be getting 1 minus x plus, from here also we'll be getting 7 minus x ZIF not equal to 6 for the first interval, this interval. Okay, for the second interval, from the first one, when the second interval is greater than equal to 1, strictly less than 7, from the first we'll be getting ZIF of x minus 1 plus, from here we'll be getting ZIF of 7 minus x only, it's not equal to 6. And the third interval, when x will be greater than equal to 7, we'll be getting from here ZIF of x minus 1, and from here we'll be getting ZIF of x minus 7 not equal to 6. Okay, so next from here, this one will imply we have a property of greatest integer function x plus n when n is an integer. Then we can write this one to be ZIF of x plus m. Again, that is what we are going to use here. So we'll be getting 1 plus ZIF of minus x plus 7 plus ZIF of minus x is not equal to 6. That will give rise to twice ZIF of minus x is not equal to, here we'll be getting 7 plus 1, 8 to minus 2. So ultimately we'll be getting ZIF of minus x is not equal to minus 1 for x is less than 1. Again, for the second case, we'll be getting ZIF of x minus 1 plus 7 plus ZIF of minus x not equal to 6. So from here we'll be getting ZIF of x plus ZIF of minus x is not equal to 0. Okay, this one for x lying between 1 to 7. And for the third case, we'll be getting ZIF of x minus 1 plus ZIF of x minus 7 not equal to 6. From here we'll be getting twice of ZIF of x is not equal to what we'll get, 14, means ZIF of x is not equal to 7 when x is greater than or equal to 7. Okay, so for the next step, we're going to conclude almost. We are arriving here. ZIF minus ZIF of x has not to be equal to minus 1 for x is less than 1. So this is what we are getting. So what we'll get from here is x should not be belonging to 0 to 1. 0 to 1. X should not be belong to 0 to 1. Okay, and obvious this one is included here. Okay, and for this ZIF of x plus ZIF of minus x ZIF not equal to 0 means x should not be an integer when x is lying between 1 and 7. And the third one, ZIF of x is not equal to 7 when x is greater than 7. So x should not be belonging to x should not be belonging to 7 to 8, because the f of x should not be equal to 7 only. So we have to remove all x for which the f of x is 7, for all x which are greater than or equal to 7. So we'll neglect this interval. So ultimately the domain of this function will be intersection of all these three. So domain of this function will be all real numbers except these intervals. So what are those intervals? 0 to 1, then union, this minus is for all, x does not belong to z for all x belonging to 1 to 7, means we have to subtract all the values, integral values from 1 to 7, 1 2 3 4 5 6, okay, union 7 to 8, 7 to 8, open interval, okay. So this one 7, this one was for x is greater than equal to 7, right? So we have to include 7 here. Or we can include 7 here. This one is open. We include 7 here. Again, so this one will be the answer.